Hello, I am audible. Anyone,
Yes, sir,
please?
you're audible.
Okay, okay. Okay, we'll start within 5 minutes. Let's wait for 5 minutes.
Sir, you look more smarter than the photograph you have put. So kindly change the photograph, sir. Your present photograph is fun. Your present posture is fantastic. with beard.
Okay, okay, thank you. Thank
I think this is a high school or something.
you. Yeah, thank you, sir. Thank you. Thank you.
सर
Yes, yes. Or no?
सर
हाँ, yes or no बोलो.
I think, sir, you're muted.
Oh, oh, sorry, sorry. Yes, yes or no बोलो.
सर एक्चुअली मेरा क्लास क्लैश कर जा रहा है। एक ही टाइम पे दो क्लास चल रही है।
और सिक्स
एक
टू 6 to 8.
जी सर, एक
कौन?
फ्लूइड मैकेनिक्स हो, एक फ्लूइड मैकेनिक्स हो गया
हाँ.
और सर एक वो सॉलिड मैकेनिक्स ऑफ सॉलिड चल रहा है।
ओके, ओके, सोम. वो सेम डे मंडे.
यस सर, सेम डे
और
मंडे।
6 to 8 वो भी है.
यस सर, अगली बार आपका क्लास इसी मतलब नहीं कर पाया। अब मुझको लेट इन भी नहीं किया गया। मैं गूगल से ज्वाइन हुआ था, मेरे को अलाउ भी नहीं किया गया और ऊपर से सर वो भी क्लास छूट जा रहा है, कोई एक क्लास छूट जा रहा है।
नहीं नहीं, इसमें इन करने का नहीं है ना, मैंने तो ऑटोमेटिक कर दिया, कोई भी आएगा इन हो जाएगा. और इसमें इन.
नहीं सर, तो मैं ऐप नहीं डाउनलोड किया था उस टाइम, बिना ऐप के ज्वाइन हो रहा था डायरेक्ट गूगल से। तो मैं नहीं था, मैं पूरा 8 बजे तक वैसे बैठा था कि अब आऊँगा, मुझे अलाउ किया जाएगा, अलाउ किया जाएगा।
नहीं नहीं, तो
फिर ऐप
एक ना,
डाउनलोड।
वो मेल करना चाहिए. मेल, अच्छा, मेल आईडी भी नहीं है ना, मैं अपना मेल आईडी यहाँ लिख दे रहा हूँ. एक मिनट,
हाँ
चैट बॉक्स में. तो एक बार मेल कर दिया करो, है ना, ऐसा अगर हो किसी को.
हम्म। सर तो एक क्लास छूट जा रही है क्लास करने के चक्कर में।
एक मिनट. ना, मैंने मेल आईडी लिख दिया. अभी किसी को ऐसा होगा ना तो वो मेल मेरे को कर देगा, है ना. मैं मेल चेक करता रहूंगा.
सर पिछले क्लास का लेक्चर कहाँ मिलेगा?
वो उसका यूट्यूब लिंक है ना.
हाँ सर।
वो यूट्यूब लिंक में अच्छा सेंड कर दूंगा, इसी में सेंड कर दूंगा ना, लास्ट में.
ओके सर।
लास्ट में मेरे को याद दिलाना. मैं लास्ट
सर क्योंकि
में.
सर
हाँ,
दोनों क्लासेस
यस
इम्पोर्टेंट है।
यस, एक्चुअली इस सारी वीडियो और एक यूट्यूब वीडियो और यूट्यूब चैनल पे अपलोड होंगी, तो वहाँ से देख सकते हो बाद में भी, नो प्रॉब्लम। ओके, आई थिंक लेट्स बिगिन।
कौन सा यूट्यूब चैनल सर?
वो मैं अभी सेंड कर दूंगा, वो जस्ट फ्लूइड मैकेनिक्स के नाम से है, लेकिन वो ढूंढने
सर मेल उसको सर मेल कर सकते हैं।
हाँ बिल्कुल बिल्कुल, जस्ट वेट।
सर सर एक क्वेश्चन था।
हाँ
और जो रिवर इंजीनियरिंग का कोर्स है उसमें से कोई कोई ट्यूटोरियल नहीं होगा? ट्यूटोरियल होगा नहीं सर?
नहीं, उसमें एक्चुअली आई थिंक कोई है नहीं टीए उसमें, जैसे कि उसमें टीए नहीं है तो इसलिए नहीं हो पाएगा उसमें।
अच्छा अच्छा, ठीक है सर।
हाँ हाँ ओके, जस्ट वेट, 1 मिनट अर्नब रुको, मैं सेंड करता हूँ ना तुमको, जस्ट जस्ट वेट।
सर वो असाइनमेंट में एक क्वेश्चन में डाउट था, तो आप पूछ सकते हैं सर?
हाँ श्योर श्योर बिल्कुल।
मैं तो उसमें लिख देता हूँ सर वो असाइनमेंट का क्वेश्चन जो।
हाँ हाँ बिल्कुल, उसमें सेंड करो। Yes sir, now I have sent it the previous video, right?
ओके सर, थैंक्स सर।
ओके वेलकम।
सर भेज दिया सर।
हाँ मैं देख ले रहा हूँ। वर्टिकल रेक्टेंगुलर गेट।
हाँ
ओके
अच्छा सर, उसका आंसर सर नहीं मैच हो रहा है, थोड़ा सा कुछ आई थिंक आंसर में प्रॉब्लम है या आई एम डूइंग रॉन्गली।
ओके ओके ओके, लेट्स डिस्कस वर्टिकल रेक्टेंगुलर। Okay, let's start. Welcome all in the week 2 fluid mechanics session. And the topic is about the first lecture was about the concept of hydrostatic, and second lecture was about the measurement of fluid pressure and fluid hydrostatic force, and third lecture was about the buoyancy, metacenter, stability and rigid body motion. So we'll move on the first question. Or before we move on the first question, let me discuss about some basic concept of the fluid statics. First, I want to discuss about the Pascal law. Before going to Pascal law, I want to discuss some concepts. So I think my slide is visible to all of you.
यस सर।
Yes, anyone please? Yeah, okay, thank you. I think I have given some figure about it. Yes, this figure is visible to all of you.
यस सर।
Okay.
थोड़ा बड़ा हो पाएगा सर तो?
हाँ श्योर श्योर, बढ़ाओ। अभी दिखा अच्छे से?
हाँ सर दिख रहा है।
Okay. So concept is that the point A, point B, point C, point A, point B, C is visible to all of you, no? Just see here.
यस यस सर।
Yes, point A, point B, point C, point D, point E and F and G.
जी।
And here water. At every point is water. And these all point in the same horizontal section. I mean, I think you are getting what I am trying to say.
सर
At the same level, if you check from the above, the each point at the same level. So at every point here and here, the pressure is same. At every point. At every point, the pressure is same. If you consider some point, let's say here, the pressure is not same as when you compare from B and this point, let's say the O.
सर आपका कर्सर नहीं दिख रहा है सर, आपका कर्सर नहीं दिख
Oh, oh, not visible.
रहा। आपका कर्सर नहीं दिख रहा है सर, कर्सर जो आप जो दिखा रहे हैं ना, इट इज the figure is visible sir, but what you are showing, you are marking something probably
Oh,
by
marking is not visible.
no, not visible sir.
Oh, why this is happening? Wait, just. Now?
नहीं सर, नहीं आया है अभी तक।
Wait, just.
आपका कर्सर मूवमेंट नहीं दिख रहा है सर।
Okay.
हाँ, अभी दिख रहा है। अभी कुछ आया, अभी कुछ आया, कुछ बदल।
अभी दिख रहा है point B, C.
हाँ, अभी दिख रहा है सर।
Okay, okay. Let me put it in this mode. I think full view mode is not working the pen, electronic pen.
सर
So let me discuss in this mode. So point A, point B, and point C. This is a very important for hydrostatic, and you will at the end of the this concept discussion, you will feel some about the how to design this hydrostatic instruments. So let's discuss. Point A, point B, point C, and point D, point E, F, and G. These all point in all same horizontal plane at the same horizontal line. Okay. When you measure the pressure at that point, point A, at each point, if you know the pressure at A, then there is no need to calculate the pressure at any point. As the concept of the hydrostatic, there is a derivation for that. Here I will not discuss the derivation. For point A, point B, point C, point D, at every point the pressure will be same, because the same fluid at point A and point B, same fluid at point C, point D, everywhere the same fluid. But see here the below one, the point H and point I. Point H and point I at the same level, but pressure is not same, because of the here is a fluid is a mercury and here is water. So for the there is two condition for the pressure equal at 2 point. So first one is the fluid should be the same, that is the same density, and the second one is the at the same level of the point should be at the same level. So this is the main.
In that case sir, the I and G and F, the I will be different than F and G, is it not?
Yes, no, here level is difference. At that level, if you draw the line, the height is that, right?
Yes.
But at the point of I, the height is different. So
Yes.
pressure is different,
Different, yes.
right?
Yes sir.
Okay. Now coming on the Pascal law, what telling the Pascal law? Pascal law actually telling about that if a fluid is confined, a confined incompressible fluid, right? Confined incompressible fluid means like that. You see the figure. This is the boundary, and in the boundary the uh, fluid is there. That is the confined fluid, right? In a confined fluid, when you apply the force, at this point, the force will be distributed every
सर
direction.
आपका कर्सर नहीं दिख रहा है सर।
Okay. Now visible.
Not visible sir.
Okay, what is happening? Now visible?
Yes sir, थोड़ा सा रिपीट कर दीजिए सर, रिपीट कर दीजिए।
Yes, sure. The concept is that when the fluid, when the someone apply the pressure on a confined incompressible fluid, let's say I want to write here confined incompressible fluid, right? When apply the force in a incompressible fluid, let's say you have applied this point, at that point the fluid force, at that point the force will be distributed in each direction at the same, that is the pressure will be distributed at same direction at everywhere. This is the concept derived by the Pascal, observed by the Pascal. So what is the, actually what is the practical use of this concept and this principle? Here is the area, is you just see the area, let's say in the mathematics 10 mm square, and this area just you assume the area is equal to 15 mm square. Okay, but as per the Pascal law, when you apply the force here in at that point, when you apply the pressure at that point, what will happen? The distribution of the pressure at each direction will be the same. Let's say what is the previous figure? I was telling about the previous figure. At the same level, pressure will be the same, like point A, point B, point C, whatever the geometry no meaning. So here is also the point 1 and point 2. The pressure will be the same. The pressure will be the same, point 1, that is the point 1. The particle point at point 1 and particle at point 2. The pressure will be the same, but area is different. So what will happen? And let's say here you have applied the 10 Newton force by some weight. You have applied the 10 Newton force. So pressure at point 1, what is pressure at point, the force by area? How much force? 10, and area is how much? 10 mm square. So pressure is 1 mm, 1 Newton per mm square, right? At the point P1, at the point 1, by the same pressure, by the same force, you apply at point 1 the 10 Newton force. Just for increasing the area at point 2, you are getting how much force? Let's calculate. At P2, the force by area, the P1 is P2 same, that is the 1 Newton per mm square, and area how much? 15. Now how much you are getting? 15 mm square. You are getting 15 Newton. You just imagine, that is the 50% of the force increasing. You apply the same forces at point 1, same force at point 1, 10 Newton, just for increasing the area in the another direction, and the another point, you get the 15 Newton. So here, what is the concept? Based on that concept, the hydraulic jack is designed. Applying the minimum area and applying the minimum force, you can get the easily maximum force for lifting the heavy load. So this is the benefit of the Pascal law, and lots of instruments and lots of devices are designed based on that only. So this is the basic concepts of the
So
Pascal law.
at point the left side is I think 1 Newton, sir, and this is 15 Newton. The right side. Number 2 is 15 Newton. Number 1 is 1 Newton. You said, sir.
No, number 1 is the 10 Newton. I have applied here 10 Newton, right?
Okay. Yeah.
Just for increasing the, here area was the 10 mm square, right?
Yeah.
Here I have considered the, because the area is more, so 15 mm square.
So 10
Just, yes, just for increasing the area, the same 10 Newton force exerted here 15 Newton force.
Yep.
That is the input is 10 and how much you getting the output? 15.
15.
So that is the main concept behind this concepts of the Pascal. So you can get easily, and if you want uh, more description and more study, so you can go through the Angel Simbala book. You will get the more detail about it. Now I don't know, and I think yeah, that is last. Now we'll move on the question answer session. The first question is visible to all of you, I think.
Yes, sir.
Okay, please. Okay, please, everyone first solve, then I will discuss about first question, second question. Just I have given the figure for just for your visualization. This figure is not related to the question 1 and question 2. Just for visualization purpose, I have given. So please go through. All of you, please participate in the question answer session. Because of I am here only for you. The first question is the in a static fluid, the pressure at a point is first option is equal to the weight of the fluid above. Second option is equal in all direction. C option is equal in all direction only if its viscosity is zero. Fourth option is option D is always directed downwards.
B, sir, equal in all directions.
Okay, it's okay. Please, all student chat in the chat box. Please write the answer in the chat box. Now open your message dialog and just write the answer to all of you. Yes, I am telling to all of you. Please, just write the answer. Okay. Okay, option B is correct. And this thing you can derive very easily. There is not much hard and fast mathematics behind it. You can derive very easily. Okay, for question 2 you go through. Yes, for question 1 the option number B is correct. And here I have given one figure to all for you. Uh, this is the point of view. Let's consider the fluid is confined. That is the static. Here is the static fluid. Let's say the point is considered 1, and here is the zoom view. So in all direction, pressure is equal in all directions. So for question number 2, the fluid static deals with viscous and pressure force, viscous and gravity force, gravity and pressure force, surface tension and gravity force. Yes, please, everyone participates. Someone telling the option number D. Option number D for which question? Question 1 and 2. Sarif. Oh, for question 2 you are telling the option number D. Okay. Okay, let's see. In fluid statics, deal with if if you all gone through the lecture video, I think sir was discuss about the what is the fluid static and what are the force we'll discuss in the fluid statics. These are only the previous year assignment question NPTEL. These questions I have not formed. This question is only from the previous year NPTEL assignment 2021 and NPTEL 2022. And I will discuss in the later about the barometer concept, how the barometer works. Okay, Singh is telling the option number B is correct, viscous and gravity force. Okay, let's see. Yes, for one is B is correct, but for two, Singh is telling option number B is correct. Pradeep is telling the option number C is correct. Okay, let's see. Lots of confusion in the participants. So let's discuss. Yes, please, everyone participates. Whatever you are getting answer in your mind, please write. Please chat the your answer. Because from this lecture you are not getting the any marks. So here is no. Don't worry about it. Your marks will be deducted from your final marks. So here just only for the live session for you, just how the questions can solve. Okay, Vidya is telling the for 2 C is correct. Okay, yes, now we'll discuss about the question number 2. I have some given here figure also. Let's discuss. In fluid statics, actually someone telling the viscous option number B is correct, someone telling, but here option number C is correct, the gravity and pressure force. Why? Because here we are talking about the force, not the viscous force and pressure force and gravity force and the tension force, and these are the combination given in the option. We are not talking here the viscosity, talking about the viscosity. So let's consider this figure. The fluid is in a static condition, the fluid is not moving.
So there is a problem.
Yes, problem in the cursor. Hello, hello. Yes. Oh, sorry for that. I think network problem.
Sir, you are not audible.
Yeah, sorry for that. I think some network problem from my side.
Yes, sir, audible.
Okay, okay. Just I am sharing my. Yes, I think visible. My slide is visible, right? Hello?
Yes.
Yes, sir.
Yes,
Yes.
sir.
Okay, okay. Oh, my slide is visible to all of you.
Yes.
Oh, but my side is not visible. Why not? Okay, let's discuss. No problem. For question number two, the question number two was about the fluid static deals with. Here is the given the combination of forces: viscous force, pressure force, and the gravity force and surface tension force. So let's consider here given the figure 3.6. In 3.6, we consider this fluid is in a static condition. A static condition means there is no velocity. Velocity is zero, right? So velocity is zero, and the viscous force is what about the viscous force is related to the shear stress, as you all know. Whatever I am writing, I think is visible, right?
Yes.
Yes, okay. The viscous force is related to this, the viscosity and the shear stress. But here, what is the fluid velocity is zero, so your shear stress zero, or you can say that your viscous force is zero, right? Viscous force is zero, so the option number A, B is gone. So here gravity force, why pressure force? You all know the we are discussing about the pressure everywhere in the fluid static. So pressure force is valid, and the only the fluid statics deals with only with the gravity force. That is the for uh, let's say this is the fluid element. Here I have taken this fluid element and just I have taken outside. So the mass of the fluid, that is the weight of the fluid, and what are the pressure force is acting on that. This thing only we balanced in this fluid static. So the gravity force and the pressure force only only study in this fluid statics, not the not the viscous force. Okay, let's move on the third question. The gauge pressure at a point is equal to. The third and fourth question is visible to all of you. Yes, please.
Yes.
Okay. The gauge pressure at a point is equal to, first one is the absolute pressure plus atmospheric pressure. Second option is absolute pressure minus atmospheric pressure. For this question, I have a figure. I will discuss before figure, then I will discuss the figure, then after I will come on the answer. C option is the vacuum pressure plus absolute pressure, and option D is the none of the above. So please give your answer in the chat box. For question number 3, Sarif is telling the option number B is correct. Okay, let's see. Or if you people participates in this, then I feel some energy. Then I think all people not participates in the live session. Whatever you join, please participate in the answer. Okay. Pradeep is also telling the option number B is correct. Okay, let's see. So pressure is measured. The atmospheric pressure is measured by the barometer. I think to all of you know how the barometer work. I want to discuss here because some people are very active. So for the that perspective, I want to discuss how the barometer works. Then I will, after this question number 3, I will discuss little bit about the how barometer work. For question number 3, someone telling that Singh is telling the option number A is correct. Okay, let's see. Gauge pressure. And you people also solve some problem out of this live session. You can go through some book problem. Why we are here solving the questions, and you just think uh, we why we need to solve the questions during our coursework, and this is the reason behind it, why we need to, because we learn these questions, how to tackle the problem and how to solve the small problem in the current scientific era. So with this mindset, you try to solve more lot of problem, then you can then you can feel the confidence. Okay, let's discuss some concept about it. Someone telling the option number B is correct. Okay, lots of participants telling the option number B is correct. Okay, let's see. First come on the concept point. Oh, before discuss about the much, first I want to tell to all of you, the pressure is a compressive force per unit area, right? Let's say this is a point. So the pressure is not like that. This is wrong definition. The pressure is always compressive. The pressure is always compressive. Let's say you consider some control volume for solving any problem. So your pressure will be acting like that. Not, let's say, when I was studying, when I have confusion about the fluid is flowing in this direction, and why we considering the force like that in this direction, this force. So the reason behind it, pressure is always acting as a compression force. So that's why we are considering the pressure force as a compression. So the pressure force is compressive force per unit area. Let's discuss about some concept. This dotted line indicate the atmospheric pressure. The how much atmospheric pressure, that is the this one, Newton per meter square. That is Pascal. This is the atmospheric pressure. Above the atmospheric pressure, when we talk about the atmospheric pressure, above the atmospheric pressure, this pressure is known as the gauge pressure. As you see, this pressure from here to here is the gauge pressure. Gauge pressure. And from absolute zero to up to the atmosphere, as indicated here, the atmosphere pressure. Below the atmospheric pressure, like at your location, the atmospheric pressure is like that, this quantity. But at some location, when you go with your barometer, when you go the some instrument for measuring the pressure, not barometer, so you will you see or so just you measure the pressure, and when you comparing, you just for at that location you might get the 10 0 1 0 0, let's say this magnitude. So that is the less than the atmospheric pressure. So at that point, your pressure is vacuum, not the atmosphere. You can say this is the at that location is the pressure is vacuum. So here concept is that when you come when you come below the atmospheric pressure, this pressure is known as the vacuum pressure. So question was about the what is gauge pressure. You can just here the option first is the absolute pressure plus atmospheric pressure. Let's see, that is the absolute pressure plus atmospheric pressure. Not the absolute pressure is what the pressure measured from the absolute vacuum, that is the pressure absolute zero. This is known as the absolute pressure. Second option is the absolute pressure minus atmospheric pressure. Let's see. Yes, atmospheric pressure from that is the your absolute pressure from here to here is, and here to here is the atmospheric pressure. You minus it, and you will minus, that is a, let's say this P1, let's say this P2. When you minus this, you will get the P2 minus P1. This quantity is the gauge pressure. That is the with this length you minus this length, you will get the this length easily. So this is the gauge pressure. The option number B is correct. The absolute pressure minus gauge pressure. One question is given based on that. Yes, please solve this question first, then we'll go for the question number 4. Question is visible.
Yes, sir.
Okay. If not visible, then I will increase some size. Yeah, now I think visible. Yes, please, everyone participates in the question answer session and chat your answer in the chat box. Write your answer in the chat box. The question is very simple, and here PSI is a unit of pressure, that is a pound force per square inch. This unit is known as the English unit, that is the like we are using the SI unit. Similarly, the English unit is also there. A vacuum gas connected to chamber and read 5.8 psi. Force psi means the pound force per square inch. At a location where the atmospheric pressure is 14.5 psi, determine the absolute pressure in the chamber. Okay, 20.3. The gauge pressure is this much, and the local pressure is this much. Okay, simply addition. You go through this concept, the figure concept, what I am telling, and you can easily get. Okay, 14.5 and 5.8, that is a 20.3. Okay, fine. Now we'll move on the. Okay, I want to discuss some concept about the barometer. Where is the. Yes. Here I think figure is visible to all of you. 3.3.
Yes, sir.
Okay.
Yes.
The concept is barometer. You just forget about this. These are these two tube. You just focus on only one tube, right? So here is what the atmospheric pressure. P atmospheric, and in this tube mercury Hg is there, right? And in this also mercury, this is mercury, and this is the vacuum part. This is the vacuum part. So when you put the barometer at any location, as vary your atmospheric pressure, the height of the mercury will increase in this. Increase or decrease. If some location, if your atmospheric pressure is low as compared to the another location, then it will decrease. When your atmospheric pressure is somewhere is more than the some location, your atmospheric pressure, then the mercury height will increase. And using the concept of this force balance, that is the gravity force balance, you just consider this and this length I am showing here. Okay, here is the weight is downward, that is the mercury weight, and force here how much, here the your pressure is the atmospheric pressure, P atmospheric, right? The P atmospheric, so your weight is how much, weight is mg, you all know, and you know the density is equal to m by v, so m is equal to rho into v, so weight is equal to rho vg, and here rho is what, here mercury is in the tube, so rho of mercury, and the volume of tube, that is the volume of tube, let's say diameter was is d, the volume of tube, so what is the volume of tube, that is the pi by 4 d square into the length say l, let's say the length is l, so this is your volume. And g, you can get easily here the magnitude, let's say whatever, and that is the weight, and here the atmospheric pressure, the P atmospheric pressure. So how, what is the P atmospheric pressure, your weight is this much, and weight by area, area is how much, pi by 4 d square, pi by 4 d square, and you put it here value, and you can get the easily what is the your atmospheric pressure. On that concept, your atmosphere, we can calculate at any location the atmospheric pressure with this calculation. Is very easy calculation, not hard and fast. And with this concept, let's move on the another question. Not this. Yes, this question. Not, oh, this one. Question number 4. I have some another diagram also for question number 4. Not question number 4. I have not any diagram, but sir, I think is explained very well in the lecture, so you can easily solve. For question number 4, yes, please everyone go through the question number 4. The question number 4 is the center of pressure of a plane surface immersed in a liquid is. Question number 4 is talking about the center of pressure. As you all know, the what is the center of pressure and center of gravity, the center of buoyancy, you all know very well. The option number A is about the above the center of gravity of the plane surface. Option B is about the at the center of gravity of plane surface. Okay, someone telling B. The option number C is about the below the center of gravity of the plane surface, and option number D, none of the above. Yes, please participate, everyone. Okay. Thiru is telling the option number B is correct. Okay. At the center of gravity, plane surface. Center of pressure of a plane surface immersed in a liquid is about the above the center of gravity, at the center of gravity, below the center of gravity. Okay. If anyone want to chat, please chat within 1 minute. Then I will discuss. Okay, Pradeep, you are telling about some PPT.
He told he could not discuss that because of lack of time. So he
Okay,
showed us
some
many
concept.
PPTs. Yeah,
Concept.
he showed us many PPTs. He told he could not cover them because of lack of
Yes,
time.
yes, yes, yes. That was related to first week. Okay, let's discuss in the second. Okay, I will discuss. No problem. Let's check the mail if anyone. No. Okay, center of pressure is not at exact on the center of gravity. Someone telling the answer. Center of pressure is like that. If fluid is there and let's say some body you have immersed in the fluid, the center of gravity of the body is this. Let's say this is 4 meter. So your center of gravity, this is 2 meter, and from here you just consider 1 meter. So your center of gravity from the top is 3 meter. That is a G. But question is about the center of pressure. The center of pressure is what the how much pressure is acting on the body by the liquid. So your center of pressure is below the center of gravity, always below the. For your detailed description, for detailed knowledge, you please follow the I think NPTEL lecture. You will definitely get the some visualization on that. How the center of pressure is below the center of gravity. This is the center of pressure. Center of pressure is always below the center of gravity. So question number this discuss, and this one is also discussed. Question number 5. Some metacentric height. Before question number 5, let's discuss some concept, then we'll go for the question number 5 and 6. So what is metacentric height? Not metacentric height. Here some I want to discuss about the buoyancy force. If you see here, my slide is visible, I think. Yes, please. Anyone tell?
Yeah, yes, sir.
Okay. You just see someone hanging with these helium balls in the atmosphere. This is the guy which is hanging through the ball. How? Because of only the buoyancy force is acting on that from the wave. Just here giving the description what I have telling, but now come on that part. So let's say consider one pond, that is a water pond, and this is the log. One dry log. Log means wood piece of wood, and this one is the weight. When you throw in this liquid both, what will happen? Your weight one sinking completely, and dry one will be not completely sink. Why? Because buoyancy force is acting, and the area of the both area, or you can say the volume of both log was same. Let's say volume is v meter cube. Volume of both log was same. So your force, buoyancy force acting on that log and on that log will be same because of the area will be same, but the density of your weight log is more as compared to density of dry. So what will happen? Mass is, what is the density? M by V, that is the mass. Mass is how much? Rho V. And weight is how much? Rho Vg. Okay, rho Vg. When you just compare from here, rho of weight log is more as compared to rho of dry. So weight of dry log is less as compared to the weight of your weight one log. So this buoyancy force is capable to hang this dry log. The buoyancy force is not capable to hang off this weight log. So I think you people visualize what is buoyancy force and why it is important, because when we design let's say you want to design a ship, so what should be the weight of your ship? How much people, that is how much people should be in your ship? This thing also consider, and what is the area of ship, like because buoyancy balance on the buoyancy force will act on each and every contact point of the fluid. So area is also matter. So lots of designing of your ship, lots of designing parameter considered based on this buoyancy concept. So this is all about the concept about the buoyancy. And sir, I think all discuss about this figure whatever I am showing, when the object in the stable condition and natural stable and the unstable condition. So please go through the question number 5. Question number 5, please. Everyone write your answer in the chat box. Question number 5 is about the condition of state equilibrium for a floating body is. Option A is the metacenter M coincide with the center of gravity G. Option number B, the metacenter M is below the center of gravity G. The metacenter M is above the center of gravity G. And the option number D, the center of buoyancy B is above the center of gravity G. Yes, please, everyone write the answer in the chat box. After this, both question will take some break of the 5 or 10 minutes. Then we'll move on the another questions. And someone telling Pradeep is telling the last PPT concept. Then I will tell some concepts about the last PPT. Okay. Option C. Someone telling option C is correct. Someone telling option B is correct. Okay. Yes, please, everyone write the answer in the chat box. The condition of state equilibrium for a floating body is when the metacentric height is above, below, coincide. Yeah, okay. Many people telling about the option number C. Yes, option number C is correct. For condition of a stable equilibrium for a floating body is the metacenter height, the metacenter point should be above the center of gravity.
So can
I
you please explain a little bit? Can you repeat that explanation that you gave? Last time?
Which one? For
The previous slide, sir, slide. Now you are explaining something. So meta center, you are explaining us what is meta center and all.
yes, yes. Okay. Let's move in the PPT mode. Yes, please. Here figure is given, I think. Figure is visible. The figure A and B.
Yes, sir.
Yes. You just see the figure B, the metacenter height here. This is the figure number B. This is the stable condition. Right. So
Yes.
metacentric height is here and the your gravity is here. Right. So metacentric height should be above the for stable, the metacentric height should be above the center of gravity. and in you just see the unstable condition. Your metacentric height is below the your center of gravity. I think visible to you, right?
Yes.
Yes. And reason behind it, why the metacentric height is below and why metacentric height is above in the stable condition and unstable condition, why is below. I think you go through some, not, I think sir it was discussed in the NPTEL lecture. If not, then I will explain. If you want, I will explain in the coming session why is above and why is below.
That will be great, sir. That will be great.
Okay. So I think you can get some visualization from here, but for the concept point of view, uh, you can go through some lecture video and definitely you will get the some visualization point.
Sure. Thank you.
Okay, this is correct. The option question number 6. Then after we'll take the 5 or 10 minute break. Yes. Question number C is correct. The metacentric height of a floating body is the distance between the metacenter and the center of buoyancy, the distance between the center of buoyancy and the center of gravity, the distance between center of the distance between metacenter and the center of gravity, and option number D is none of the above. For question number C, please everyone write the answer in the chat box. Yes, please anyone write the answer in the chat box. Hello? Yeah, I am audible. Yes, please. Anyone tell?
Yes, sir. What is?
Yes, sir.
Oh, okay. Are you solving the question number 6?
Yes, so we have already solved, sir. Many
Okay,
things.
okay, okay. Okay, for question number 6, your answer is, let's say, for question number 6, the metacentric height of a floating body is the distance between the metacenter and the center of buoyancy, the distance between the center of buoyancy and the center of gravity, and the distance between the metacenter and the center of gravity, and the D option, none of the above. Your option number C is correct. The metacentric height is of the floating body is the distance between the center of gravity and the metacentric point. Yes, I for question number 6, the option number C is correct. For question number C, for question number 6, option number C is correct. Okay, this concept we have discussed, and this one also. Before going on the above question, let's discuss first this question. Question number 9 and 10. Okay. Okay, please. I think for 5 minutes we take break, and then after we'll start question number 9 and then. Okay. Within 5 minutes, I think 1916 will come on the 1925. Okay, we'll resume on 1925. So please be there. Don't leave the class. Yes, please, if anyone having the doubt, please you can ask before 25, before 7:25, within 2 minutes, if you have any questions. Okay, please, everyone go through the question number 9. Okay, please, everyone go through the question number 9 and give your answer in the chat box. Write your answer in the chat box. So, question number 9 is the atmospheric pressure held in term of water column is how much? That 7.5 or 8.5 or 9.81 and 10.3. As I have discussed in earlier question, the atmospheric pressure is measured by using the barometer, and in the barometer is what? The mercury. And what is the pressure? That is the 7. The general, in general way, the atmospheric pressure is a 760 mm of mercury. So at the place of mercury, when you use the water in the barometer, then how much the height will be? That is the for 7.5 meter of water or 8.5 meter of water and 9.81 meter of water or 10.3 meter of water. When you measure the atmospheric pressure using the mercury, then 760 mm of mercury, that is the 760 mm of Hg. The notation of mercury is Hg. When you measure the same pressure at same location using the barometer, but at the place of mercury you put water, then how much height in the tube? That is the I have discussed earlier, just I think in the question number 4 or 5, what concept of barometer. Based on that you can calculate very easily, and this is the very basic concept and very important concept I will discuss. Please give your answer within 2-3 minutes, then I will discuss about the question. How can you solve? Please everyone attempt the question, because it when you try to solve the question, then it will enhance your indirectly your mind how to tackle the question and how to solve the problem. Whatever problem you getting in your life, then you can easily, when your mind was trained like that, you can tackle any problem, whatever in your class or in life, you can easily tackle. So please don't hesitate to attempt the question. Whatever you are getting, no problem. Okay, please anyone write the answer. You think on the concept what I have discussed earlier on the barometric question in case of barometric questions. Uh, Based on that concept, that is the only the balance of your weight and atmospheric pressure. You balance the atmospheric pressure and weight, easily you can get. And how we will calculate the weight I have discussed. Weight is equal to mass into acceleration due to gravity. And how you will calculate the mass, the relationship between the density and volume and mass you know, and you can easily calculate. Yes, I am audible. Please anyone tell.
Yes, sir, audible.
Okay. Are you solving the question? Okay, now I want to discuss the answer. No problem. I want to discuss on the new slide. The question is telling is this. You have barometer with mercury, like here. Figure is visible, all of you? Yes, anyone please tell. What I am drawing visible? Hello? Oh. Network problem. What is happening? Yeah, I think I have lost my connection.
So you're not able
Yes,
to
yes, yes, yes. I think I have lost my connection, so sorry for that.
yeah.
Now I am sharing. I think today is what is happening here. I don't know. Okay. The question is that now I think I have whatever I have drawing is visible. This is the
Yes, sir,
mercury.
visible.
Okay. The question is that you using the barometer for measuring the P atmospheric at same location, not in another location. And you know already the P atmospheric in terms of mercury is 760 mm of Hg. And the density of Hg you know very common, kg per meter cube. Okay. The question is that when you use the water at the place of mercury, what will happen? And this height here meaning is the 760 is this 760 mm in mm, not meter, in mm. When you use the water at same location, let's say I am measuring the Guwahati here where I am staying, the same barometer instrument I have put same location but with water. How much the height in the water, it will decrease or increase, or what will happen? Let's see. That is a, this is closed. Let's say here. Then what is the height of this? Or here also the atmospheric pressure is acting. This height is here water H2O. Rho of H2O you know all about the 1000 kg per meter cube. The question is asking what is the H value. Question is, I think everyone understand. Everyone getting the question? Yes, please, anyone tell. Everyone got the answer? Everyone got the question?
Yes, yes.
Diagram? Okay.
Yep.
Okay, now move on the problem. Now move on the solution part. The P atmospheric with Hg. Why I am equating the both? Because of you everywhere. I mean, you at same location you measuring only the P atmosphere, not another pressure. That is the H2O. Using the mercury and the pressure is equal. Obviously, atmospheric pressure, whatever you are measuring with oil and water and mercury, the pressure will be same at every time with any one fluid, with any fluid. So here is formula is what? The pressure formula is rho is equal to, earlier I was discussed. This is the your column, your this column. What was the formula? That is the rho gh. This is the pressure in downward, and this is the pressure that is the atmospheric pressure. So rho z, not this one is rho gh. So here rho of mercury hg into g into h equal to rho of water into g into your height, whatever height here given. Let's, here I am putting the capital H. Your capital is given is 760 mm. You put here 760 in meter, 0.76 G, both side cancel out, and the density of mercury is 13600 equal to water density 1000 into G, cancel out both side because, and H. When you calculate the H, how much you are getting? Yes, please. Anyone tell? Yes, please. Solve the using calculator. You solve and write the answer. This is a very basic concept. Only the force balance, only the weight and pressure, atmospheric pressure balance. Whatever we discussed earlier in the fluid static, we discussed about only the gravity force, that is the downward force exerted by the liquid or gas, whatever, and the pressure balance. Now, how much you are getting? Please, anyone write in the chat box. Like here, capital small h is equal to. I want to write here. Small h is equal to 3600 into 0.76 divided by 1000. How much? 13.6 into 0.76. How much getting? Let's calculate 13.6 into 0.76. 13.336. 13 not 10.336. You just say that 10.3. 10.3 meter H2O. That is your 760 mm of Hg is equal to 10.3 meter of H2O. This is the conclusion. This is the conclusion of your question, of this question. Okay, someone right here. Okay, good. Everyone got the answer? Everyone got the concept behind this question? Okay, now move on the another question. Below question is you just read and solve the question. And I have some problem in the last. You just take a screenshot of the question and solve. It will enhance your understanding about the hydrostat. I have lots of problem. You just take the screenshot. I will show. The question number 10. Please solve the question number 10. A submerged body will be, for question number 10, option number A is correct. Correct, Pradeep is telling. Okay. Another one, please also give your answer in the chat box. A submerged body will be unstable equilibrium if metacenter lie above the center of gravity. or this is the same? Not. Okay. Here is talking about the submerged body, not floating body. In case of floating body, we are discuss about the we were discuss about the metacentric height. But here is asking the question: submerged body will be in unstable equilibrium if metacenter lies above the center of gravity, metacenter is below the center of gravity, metacenter is coincide with the center of gravity, and difficult to say. I think this question is the submerged body, asking about the submerged body. Okay, let's see. Okay, I think in case of submerged body, we are not discuss about why this question is framed like that. Okay, we'll discuss about the question number 10. Okay, I will give the comment on the question number 10 in the coming class because I have some doubt on the question number 10. Yes, question number 7 and 8. Please go through the question number 7 and 8. A streamline is a line, option A, which is along the path of particle. Option number B, which is always parallel to the main direction of flow. Across which there is no flow. Option D is on which the tangent draw at any point give the direction of velocity. Question number 7. The streamline, I think you have already seen the videos, and I think streamline question is not related to the hydrostatic. This question is related to the fluid kinematics. But in the previous year, this question is include. This question was included in the hydrostatic. So let's solve. Okay. Pradeep is telling the option number A is correct. Yes, anyone please? Okay. Sarif is telling the option number D is correct. Okay, let's discuss. Okay, I will give some concept here also. What is a streamline, path line, and a streak line? Three line I will discuss. This discussion will also I will do in the fluid kinematics also. Okay, let's discuss. What is streamline? Okay. Basically, let's consider a body and fluid is flowing like that. This is the path of fluid. So this line is known as the streamline. So basically this line is known as the streamline. You take one line here and just visualize. When you draw the tangent, you draw a tangent. This is give the velocity vector. Every if any point you will draw tangent, this line give you the velocity vector. So option number D is correct. Streamline is a line on which the tangent draw at any point give the direction of velocity. Option number D is correct for that. Streamline. And what you and the path line and also what is a streak line. Okay, I will discuss in the coming session, not here. This is the not relevant here talking because of the this is a static fluid static. Question number 8. For a liquid, will capillary rise or fall, increase or decrease with the rise in temperature? This is also very important question, very conceptual question. Yes, please take the attempt this question. For question number 8, for a liquid. Okay, with this question we'll finish today session. And in the last, I have the lots of question. You just whoever have joined right still, you take the screenshot of the question and if you have any doubt, if in the coming class we'll discuss on that question. For question number 10, okay, Sarif is telling you could you please mention the correct answer of the question number 10? Okay, Sarif, I will tell the question number 10 answer in the coming class because I have also doubt in the question number 10. I think some typing mistake or anything. I will discuss with my professor and also I will go through the lot book, then I will discuss. Question number 10. For 8, okay, you telling the option D. Okay, let's see. Option D or option what way, which one correct? Let's see. because in the submerged condition we were talking about only this buoyancy, that is your point of buoyancy and center of gravity, not the meta center. And why I think some typing mistake at the place of submerged. Okay, we'll discuss in the next class. Okay, for question number 8, now I want to discuss some concept. Question number 8, for liquid the capillary rise, you all know the capillary rise is like that. One tube is there, and here height is increased. This is the capillary rise phenomena. So what is the formula of capillary rise? This H, this is the height of it, H. If consider the water, then 4 surface tension in divided by rho z, right? As increasing the temperature, and here is talking about the liquid. As increasing the temperature, as increasing the temperature increasing, the surface tension of water will decrease. Why decrease? Or surface tension of liquid will decrease. Why? Because as increasing the temperature, the molecular interaction force will decrease. The molecular interaction force will decrease. So surface tension, due to this, surface tension will be decreases. Surface tension will be decreases. So that's why, as increasing the temperature, uh, capillary capillary rise phenomena decrease, because surface tension will decrease and also H will be decrease. So option B is correct here for question number 8. For question number 8, option B is correct. Yes, if you want some, I have some collection of question. You take the screenshot and solve the question. This will enhance your problem solving techniques. And if you have doubt, then we'll discuss in the another class. So we have discussed the 10 question. Now the question number 11 is visible. If anyone please tell the question number 11. Hello? Hello?
Yes, sir, visible.
Okay, you want the screenshot of question number? All questions?
Yes, sir, we want.
Okay, if you want, then I will show. No problem. Yes, I will put it in the full view mode. You take the screenshot.
Yeah.
Oh, it's done for 11. For 11, question number 11, yes, screenshot done.
Yes.
Okay, for question number 12, you can also take. For question number 12 and 13.
12 is not coming, sir.
12 is not visible.
No.
Oh, what is happening? I think some network issue today. Now visible.
Yes.
Okay, you take the screenshot. Question number 12. Then question number, oh, here I have this. Okay. The question number, this is the problem solving only. You can take and you can see how we can solve the question step by step. When you solve the question, then you feel confident in any particular subject. Now coming on the question number, this is the example question only. The pressure measuring with the manometer, and here some U2 manometer. You can see the pictorial representation of U2, how look like the U2, not U2 manometer. Now question number 14, you can also take the, it's done. Hello.
Yes, sir.
Okay, for question number 14, and okay, that is done. And I think some similar question is given in the second sheet. So that is a, already I have tell about the what is absolute pressure and this. So no need to take the this, or no need to take the screenshot of these are the questions. Already we have discussed. Some formula is there. If you want to take the, you can take. This will be help in your problem solving. And why metacentric is a high metacenter, that is the center point is more as compared to the center of gravity. Here the below one formula I think you visible, right? This one.
Yes.
Okay, this is this yp represent the center of point and yc represent the center of gravity. So this additional term is included when you accounting, when you calculate the center of gravity. This additional thing will increase the depth of the center of pressure. Okay, some question is also there if you want to take the new questions. Now this is also very important question, you can take. These question you solve, definitely these question is also help in your final exam, in your university or also in the NPTEL final exam. Okay, done. Okay, to all of you, thank you for today. We'll see you again in the coming Monday, 6 to 8 p.m. Okay, thank you, Sharif.
Thank you, sir.
Okay, okay. Thank you, Pradeep. Thank you all. Now you can leave the class. Yes, Matthew. Hello, Matthew. Do you have any doubt? Matthew, I am audible.